Okay, so we're starting with 14.2 hours, and we want to go to seconds. So now you may not know directly how many seconds are in an hour, which you may, but I will assume you don't. But you probably know minutes in an hour, right? So that's one step to kind of get you down the line. So how many hours equals how many minutes? 1 hour is 60 minutes. Okay, so which goes where in that factor? 60 minutes has to go on top. 1 hour goes on the bottom because hours has to cancel, right? So hours here, so hours has to be down here. And then 60 minutes. Okay, now I'm in minutes, and I want to be in seconds. So what conversion factor do you know for minutes to seconds? Okay, right, 1 minute equals 60 seconds. So, same thing again. If I've got minutes on the top here, then I got to put minutes on the bottom here for it to cancel, right? So, how many minutes? Oh, 1 minute is 60 seconds. Okay, well, let's try that in our calculator. So, 14.2, okay, it's on top, so times 60. It's on top times 60, so 14.2 times 60 times 60. And I get a big long number here. I get 51,120 seconds. Okay, so let's go back and check our sig figs here. So how many are there then in 14.2? Okay, yes, that is a measurement. So we had to measure that, so that's 3. How many are in 60 minutes? 1 or exact? Why is that exact? That's been defined to be true. Yes, it's exactly 60, right? It's not measured, it's around 60. So this is exact. How about 60 seconds in a minute? Also defined to be true, right? So that's exact. So 3 exact. The fewest is 3 sig figs, right? So how would I round that off to be 3? 51100. That's one way to write it. All right. So yep. So that's 3 sig figs. We could also write it our little new fancy way. 5.11 times 10 to the 4th second. Right. Yeah. So either way is technically okay. Although this is the more preferred way in science because again, right. So this one here clearly shows 3 sig figs. This one here, it's got these weird end zeros. Yeah, so we like those if we can get rid of them. Question on that one? How'd you do?
Wait, I thought we were supposed to get the 3 sig figs because there's 2 o'clock. What was this the rest?
Whatever. Okay. So the way it works is it's always the fewest when you multiply and divide. This is 3. This is infinite. This is infinite. So 3 is the least. So 3 is the least. Okay, you try this one. How many inches are in 2.7 miles? Try it out. Pull out your handout. Hope you get your handout so you're not having to write these things down. Try it out, then we'll talk it over here in a minute. Again, the handouts are on Blackboard. I also emailed them to you. But they're on Blackboard. So for Monday, you definitely want to print out the Chapter 2 one and bring it for Monday if you don't already have it printed out. But this is still Chapter 1 for now. Okay, so we got 2.7 miles. So in a sense, you always know at least one piece of the puzzle because you know the very first conversion factor, whatever it is, we know it's got to have miles down here in the bottom, right? You always know that because it always has to cancel like that. So I got to have something that has miles in it. What do you know that has miles in it?
1 mile.
1 mile equals 5280 feet, right? So 1 mile equals 5280 feet. So in a sense, it really helps you in the way you're setting up because almost like, it almost like guides you what the next unit has to be. Oh, well, when I got feet on top, So whatever one I have here, it's got to have feet on the bottom, right? See how that works? You can always kind of see. Oh, so now I need something that has feet, and I'm trying to get to inches. So here you go. 1 foot, 12 inches. So let's put 1 foot on the bottom, 12 inches on the top, and now feet cancels. So I'll punch out my calculator real quick. Sure you already did, but oops, wrong button. $171,072 inches. Okay, well that's a whole lot of digits. Let's see which of those are actually significant. So 2.7. How many is in that? 2. 5,280. How many is that? 3 are exact. Why is that exact? Because that's been defined, right? Those are both English. Miles and feet are both the English system. Remember I said if it's same system, English to English. Did I say that last time? It's exact. So that has been defined. That never changes, right? It's not some days it's 5281. No, it's always 5280. How about 12 inches in a foot? That's been defined to be true, right? English to English. Same system. That is exact. Okay, so 2 exact. What's the smallest? 2. Awesome. So we need 2 sig figs here. So, round that off. Keep the 1 and the 7. I'm going to make it scientific notation just to make it nice and neat. 1, 2, 3, 4, 5. So times 10 to the 5th inches. Yay! Good. Is that what you got? You seem thrilled. Okay. I'm going to skip this one. Okay, let's try this one. And I want to do it with you. So this says a .38 special revolver uses bullets, but are not actually 0.38 inches anymore. They're 0.357. Again, I skipped one. I went to F. What is that diameter in millimeters? So let's start with what we know. We know 0.357 inches, right? Okay, I want to get to millimeters. Well, I don't see in inches to millimeters, but I see in inches to centimeters. So I guess I'll start with that one. So let's try 1 inch is 2.54 centimeters. So now I need something that has centimeters down here, right? Okay, well, I'm going to go from centimeters to millimeters. Well, you probably don't know that conversion, but what do centimeters and millimeters both have in common? Meters, right? They both have meters in common. So what you can do is you can go centimeters to meters and then meters to millimeters. So let's try that track and see how that works. So centimeters to meters. What's centi mean? 10 to the -2, -2. Will that go on the top or on the bottom? It should be quick and easy. Top or bottom? Yes. Why is it the top? Yes, right? Here's the prefix on the bottom. It always goes opposite. Opposite, right? That's on the bottom. This is on the top. Okay. 10 to the -2. Okay, so let's try the next one. So, okay, now I'm in meters, and I want to go to millimeters. So I'll just keep going down here. Now I'm in meters. I want to go to millimeters. What's milli mean? 10 to the -3, right? 10 to the -3. Top or bottom? Now, why is it bottom this time? It was top last time. I'm so confused. Yeah, it has to go the opposite. Here's the prefix. So the exponent has to go opposite, right? Okay. Perfect. Now, so go through centimeters cancels, meters cancels, and we're left with millimeters, right? This is what we want, right? We got our millimeters. Awesome. Okay, so let's try this on our calculator. And I want everybody please to try that. And let's try to use the exponent key, okay? Okay, try to not use 1, 0 to the power of. Try to use your exponent key. It really is a lot faster in the long run. In the long run, it is a lot safer too, because you can get in lots of trouble doing it the long way. So you ought to be entering this something like 0.357 times 2.54 times exponent key -2 divided by exponent key -3. Something like that you should be entering. So try that out in your calculator. Let's see what you get. So point times 2.54 times exponent -2 divided by exponent -3. And if your exponent key is giving you an error, then you may need a 1 before that exponent key. So again, some of you may need a little 1 in there. So I did it, and I got 9.0678. Is that what you got? Okay, quick timeout. Who needs help? Calculator. Let's try it out. Yep, so you need a 1 on yours for sure.
I do. I've been doing 10 and it's been working.
10 times 10?
Or no, I do 10 exponent.
Oh no.
But
So,
it's been working well. But I'll try it.
okay.
0.
Because you're adding in an extra power of 10, it shouldn't be working.
Huh.
Although I guess if 1 is multiplying and 1 is dividing, then they're canceling out. So it might just happen to be that way. But if not, you're adding in a 10 times 10 to the.
Okay, so make sure I add a 1. Like
Yes,
this,
do a 1.
like this one here. Like this one worked out fine.
Show me it.
At the time. I did 340
No offense, but I don't believe you.
times 10.
Nope.
Oh. 340. Is it divided by?
Mm-hmm. Divided by. It's supposed to be 0.34, we said.
Oh, was it?
So yours is 10 times too small because you put an extra 10 in there.
Okay.
So yes, 1 exponent.
1, okay.
Question. It would have been alright just to go straight from CM to millimeters.
Yeah, that's fine too.
Just a lack of scientific notation.
Well, I mean, it still works out, I guess. If you happen to know there are 10 millimeters in a centimeter, you can do that if you know that. Yeah, that'll still work out, math. Okay, anybody else have a problem with their calculator real quick?
B?
So y'all got that answer? Oh, yeah. Okay, you need the 1 in front of the exponent on yours.
Yeah, I was gonna say, I just don't know how to do the negative.
Right here. Here's your negative right there.
Oh, okay. So if
Yes,
I
you.
wanted to do 10,
No, don't do 10.
like
Don't do
that?
10. Do 1.
1? Okay.
Because the EE already means 10 to it. So if you do 10, now you added an extra 10 in there. So do 1 exponent. So you would do 1, 1 exponent -3. And that means 10 to the -3.
Okay. Thank you.
Yeah, so just try it out basically then like this on the board if you can. 0.357 times 2.54 times 1 E -2 divided by 1 E -3. Yeah.
Will this be what
I hate your calculator.
Really?
Yes. I hate this one because you have that little times 10 to the thing and it doesn't work like an exponent key.
This one? Are you talking about?
Like that.
Yeah, because that's really not an exponent key. This is really, it's an anti-log. So you have to use lots of parentheses. This
Okay.
is more of like a.
Well, I know you didn't believe her, but it's been working for me. So
Even when you do a number with it?
yes, this was.
What if you do a number?
I did.
Okay. Okay, let me. Okay, how about on this one? I'm curious how this one will work then. Because this one you have a number in front of the exponent, and sometimes that's where it gets you. Especially if the number's on the bottom and you are dividing, because it'll divide by the 5.22, then that times tells it to put it on top. You know what I'm saying? So for example, if I wanted to divide by that, oops, I'm sorry, what do you do times what you did? Like this. It divided by 5.22, but then it multiplied on the top by 10 to the third. It's not putting it
Got it.
together. So that's where it screws you. On those notations like that.
So this E to the X would it be in my button? The green? No.
No, No, the E is the inverse natural log. That's not the mouse. Okay, so quickly, sig figs here. Let's 0.357 has how many sig figs? 3. How about 2.54 centimeters in an inch? 3 or exact? Why is that one exact? Because that's English, that's metric. Why is that exact?
Oh, because it says it's the only one.
That is the only exact English to metric. Normally, English to metric, you would have to count it and say 3. But remember, I told you that's the only one that was defined back in 1970, so at least there was one exact connection between the two systems. That's the only exact one. Every other English metric, you'd have to count them out and say, oh, that's only 3. How about 10 to the negative 2?
That's exact.
That's exact, right? Right, you're scaring me.
Yes.
Right, both are metric. That's been defined to be true. You memorized it. That's exact. How about 10 to the negative third? That's exact. That's been defined to be true. So how many sig figs should the answer have? 3 is the fewest, yes. So you would round that off and you would say 9.07 millimeters, right? Something like that. Yay. Okay. Yes.
Can we do E? Just because, or maybe you can help me with it. I just don't know how to enter it into the calculator instead of they're both on there.
So whatever is on the bottom, always divide by.
So it would be
This divided by 16, divided by 2,000.
so this divided by this divided by this.
Yes, right.
Okay.
Okay. I'm going to do one more with you. Let's try.
The ones that we skip are we supposed to
Let's
do
do
it
this
our
one.
own?
You can always do one on your own, only for practice. Yeah, sure, do it for practice.
We don't have to.
You don't have to do extra practice if you don't want it. But yeah. Okay, so let's try G. How many ounces are in 5.22 times 10 to the third? What the heck is a DG? Bah. What was that? Deci. D means deci, right? You learned that, hopefully? Decigrams. That's decigrams. So let's try this real quick. 5.22 times 10 to the third decigrams. And I want to go to ounces. So, well, I see ounces and pounds, and I see pounds and grams. So what could I do first?
Convert to
Convert decigrams to grams, right? Okay, so decigrams has to go on the bottom, so it will cancel. So grams goes on top. What's deci? 10 to the
1 or negative.
negative 1. Top or bottom?
What do you mean by top or bottom?
Top or bottom? 10 to the negative 1 has to go on the top. Opposite of wherever the prefix is. The deci's down here, so this has to go. Yes, exactly. Yeah, on the bottom it would be like saying decigram. So now it's decigram on top, decigram on bottom, basically. Yeah, getting it? Okay, right? Because they're always the opposite, right? So the deci was here, so the exponent goes here. Opposite. Okay. Now we're in grams. So I need a conversion factor that has grams. What do you see up there that has grams in it? 1 pound is 454 grams. Okay. Now I'm in pounds, so I need a conversion that has pounds in it. What do you see that has pounds in it? Ounces. 1 pound is 16 ounces. Okay, so let's cancel everything out. Make sure it cancels. Decigrams, decigrams, grams, grams, pounds, pounds. We're left with ounces. Okay, looks perfect. So let's punch this in our calculator. So, I'm going to say it again for the umpteenth time. When you're entering this into your calculator, whatever you see on the top, multiply by. Whatever you see on the bottom, just divide by. That's the easiest way. So I would take 5.22 exponent key 3 times exponent key negative 1, or some of you, 1 exponent negative 1. Oh, that's on the bottom. Divided by 454. That's on top, so times 16. Are you with me? So everything on top you multiply by. That's the easiest way. Everything on bottom you're dividing by. So try that out, see if you can get the answer. I'll try it out too. Okay, I got 18.396 for a whole bunch of garbage. Okay. So let's figure out our significant digits on this one. First off, how'd you do on that? Did you get 18.39? Are you entering it the way I told you, or are you just doing your own thing? Multiply, then divide, then times. Right? That's the easiest way, I promise you. It'll save you so much time once you get that down. Okay, let's look here. How many sig figs are in 5.22 times 10 to the third? 3 sig figs. How many are in 10 to the negative 1 grams of the decigram? That's been defined, right? Metric to metric. That's been defined to be true. That is exact. So infinite sig figs. How about 1 pound is 454 grams? 3 or exact? Okay. So the question is this English, metric, or English to metric? That's English going to metric. So those are never exact, except for the one we just showed you, right? So that one is, in fact, 1, 2, 3 sig figs. Okay, time out. Everybody got that? It's English to metric, right? Those are not exact, except for the only exception, 1 inch equals 2.54 centimeters, right? Okay, 16 ounces is a pound. Pounds are English, ounces are English. That's defined, that's exact. And I mentioned last class, of course, that the ones are always considered exact. So those are always considered exact. So we got 3 exact, 3 exact. What's the fewest?
3.
Obviously 3. So I'm going to round that off and get 18.4 ounces. Perfect. Yay. Okay. Okay, I'm going to skip the next one. We got to roll on, people. Okay, well, let's talk about percentages, ppm and ppb. You know what ppm means? You've probably heard of this at some point in your life.
Parts per something.
Parts per something. Good answer. You're very close. Parts per what? What do you think? Meter? Good guess, but no.
Parts per measure.
Measure? Good guess. Okay, one is M, one is B. Maybe that helps. What's 2 things that might be related?
Parts per mass.
Mass and bass?
Mass and
Million and billion. Million and billion. Parts per million. Parts per billion. So you always hear this, well, not always, but you hear this frequently. It's at the EPA, and they're measuring the water quality, and they only allow so many parts per million of lead in your water, or so many parts per million of fluoride or cyanide or whatever. So percent is basically parts per 100. It's out of 100. So any kind of a percent is the part you're interested in divided by the total number times 100. Right? This should be old news to you from any math class sometime in your life, back in like 3rd grade or something, right? The part over the whole times 100, right? So that's a percent. So let's say, for example, I want to know the percentage of, I don't know, blondes in this room, right? So I would go around and I would add up the blondes, divide it by the total number of people times 100, right? The part you're interested in over the total times 100. Okay, so for example, let's say you have a food that says on the label that's 15% by mass fat. Well, 15%, that's 15 out of every 100. So if it's by mass, I could say, oh, that must mean there's 15 grams of fat out of every 100 grams of the food. It's by mass, right? So it's 15 out of 100. If it's 5%, it's 5 out of 100, right? If it's 0.3%, it's 0.3 out of 100, right? Percentage is always out of 100. Like in your grade, right? So your grade is 90%. Oh, you got 90 out of 100. Right? Okay. But now it's by mass. So the only important thing, though, is that these units have to be the same. So you don't have to use grams. It says by mass. as long as they're both the same mass units. You could have said 15 milligrams out of every 100 milligrams. As long as they're both the same, 15 out of 100 of the same thing. Or you could have said 15 pounds out of 100 pounds. As long as they're both the same thing. Okay, just 15 out of 100. So 15 people out of 100 people, right? You're comparing the same thing. And we learned before, right, that any conversion like this, you can always flip it. Remember, you can always flip it either way. It's true, right? So 12 inches is a foot, or a foot is 12 inches. You can always flip any of these. So let me just highlight one more thing again, right? As long as these are the same unit. So you can't say 15 grams out of 100 pounds. That doesn't work, right? Or you can't say 15 milligrams out of 100 kilograms. That won't work for this, right? It's got to be the same unit, right? 15 puppies out of 100 puppies, right? Are black puppies or whatever, right? 15 trees out of 100 trees are maples, right? It's got to be the same thing. Yes? It'll be the same thing. Okay, so don't mix and match units. That will bite you in the ASS. Okay, so let's try an example real quick. And now we're going to use this percentage as a conversion factor. So, the human body is composed of 65.0% oxygen. How many kilograms of oxygen are in a 75 kilogram person? Okay, so let's try this out here. I have a 75 kilogram man, person, human, whatever you want to write there. And I want to figure out, okay, out of that 75, what mass of that is oxygen? Well, I know that in the standard person, it's 65.0% oxygen. And I'll use O, as you might know, is the element for oxygen. If not, don't forget element quiz next Wednesday. Right, element quiz next Wednesday. So you know by next Wednesday for sure. Okay, so 65.0% is the same as saying, oh, well, there's 65 whatever unit I'm using out of 100 of that same unit, right? Are you with me? That's the same as saying, oh, 65.0 whatever oxygen out of 100 whatever, and the total is man, right? So, again, I could use 65 grams out of 100 grams, 65 kilograms out of 100 kilograms, 65 pounds out of 100 pounds, whatever unit you're interested in, okay? There's no set, it has to always be this unit. So in our case, we're interested in kilograms. So let's use kilograms. Let's make it easy on ourselves. So 65.0 kilograms of oxygen are in every 100 kilograms of person. See how that works? Okay, awesome. So let's plug that in here. So I'm in kilograms of man. So I need on the bottom, I need kilograms of man. Oh, well, how many kilograms of man? We just figured it up. 100 kilograms of man is 65.0 kilograms of oxygen. So we cancel kilograms man, and we're left with kilograms oxygen. Okay, so try that out. 75 times 65.0 divided by 100. And I got 48.75 kilograms of oxygen. Okay, let's look at our sig figs here. How many sig figs are in 75? 2. How many sig figs are in 65.0? How many sig figs are in 100, do you think? Okay, actually it's not 1. This one's actually exact. Why is this one exact? It's defined, right? Right? It's always out of 100 for a percentage, right? It's always, always, always out of 100. So the 100, in a sense, is defined. The other one was measured, right? That was measured, right? That was measured in a person, but the 100's always in a percentage. It's always 100. So we got 2, we got 3, we got exact. What's the fewest? 2. So my answer has to be rounded off to 2 sig figs. So how would you round that off for me? 49 kilograms of oxygen. Again, element, symbol, and name quiz, right? Next Wednesday. Okay, let's try another one here. Okay, let's say you're working in a hospital. You have to give a patient an IV saline solution. Most saline solutions are 0.9% sodium chloride. Okay. If the total bag contains 1 kilogram of solution, how many grams of sodium chloride does it contain? So 0.9%. Okay, 0.9% means there's 0.9 out of 100, right? 0.9 sodium chloride out of every 100 whatever solution. Again, you can use grams to grams, kilograms to kilograms, whatever you want to do, in a 1 kilogram of solution. So I'm trying to take the kilogram of solution and turn it into grams of sodium chloride. Right? Back up here. So I have 1 kilogram of solution, and I'll use the little abbreviation here for solution we like in chemistry. SOL apostrophe N. We like to use that. And I'm trying to get that into grams of sodium chloride, and you don't know quite yet, but that's Na and a Cl, sodium and a chlorine. So I want to get from solution to sodium chloride. Well, this 0.9% thing, that tells me there's 0.9 sodium chloride in every 100 whatever of solution. Does that make sense? Right? Do you see where that comes from? No? Yes? Because it says it's a solution that's 0.9% sodium chloride. So 0.9 sodium chloride out of the whole solution. So I need to use this somewhere in here as a conversion factor to get from solution to sodium chloride. So I really have two options. I could use it first and then turn kilograms to grams, or I could turn kilograms to grams and then use it second. There's really two ways I could do it, so I'll show you both. So let's do it first with the percentage here. So I'm going to do a little erasing just to make room here. Okay, so if I want kilograms of solution on the bottom, then I'm going to have kilograms of sodium chloride on top. So for every 100, I've got 0.9. Are you with me? This comes from the 0.9%, right? 0.9 out of 100. And since that was in kilograms, I made this both out of kilograms. Okay, now I'm in kilograms of sodium chloride, but I want to be in grams of sodium chloride. So let's do that. So kilograms, running out of room, sodium chloride. I want to go to grams sodium chloride. What's kilo mean? 10 to the third. Will that go on top or bottom? Top or bottom? Yes, please, for the love of the children. You should know by now. The kilo's on the bottom, so the 10 to the third goes on the top. Okay, good. And that'll do it. Now I'll be in what I want. Grams of sodium chloride, right? That's what I want. Right here it says I want grams of sodium chloride. Okay, so punch that in your calculator. So you're going to take 1 times 0.9 divided by 100 times exponent 3. I'll say that again. 1 times 0.9 divided by 100 times exponent 3. One times 0.9 divided by 100 times exponent 3. I got 9. What'd you get? Okay, perfect. 9 grams. Okay, now let me just show you just the other way, just to prove to you that it works, even though I don't really have time, but I want to do it anyway. 1 kilogram of solution. Again, I could have done this part first, kilograms to grams first. I could have said, oh, well, for every 1 kilogram of solution, there's 10 to the third grams of solution. Then I could have used a percentage here and said, oh, well, for every 100 grams of solution, there's 0.9 grams of sodium chloride. and you still would have got 9 grams. Okay, let's think about that for a second. It all works out the exact same mathematically, right? So I could either use the percentage first and then turn grams to kilograms, or do that first and then do the percentage. Mathematically, it works out the exact same way. And still, these are both on top. This is on bottom. The same way. So however you want to do it, there's no certain like, oh, you have to always do the percentage first. No, you can do the percentage first or the metric conversion first. Either way would have worked. Okay, I'm going to skip C just for time's sake, but again, you can always go back and do it on your own for practice. Ask me sometime for the answer if you're not sure. Well, how about parts per million? So I said percentage is basically parts per 100, right? It's basically 5 out of every 100. Well, parts per million is basically out of a million, okay? So let's say, for example, in tuna, for example, the EPA only allows there to be 0.5 parts per million mercury in your tuna. So that means out of every million parts of tuna, there can only be 0.5 parts of mercury. So, how about grams? We're going to do it grams. So out of every million grams, right? So here's a million, 10 to the 6. Every million grams of tuna, there can only be 0.5, right? Percent would have been 0.5 out of 100. Parts per million is 0.5 out of a million. Did I just lose you? You give me the blank look. This is the same as a million, right? 10 to the 6 is a million. Because 1 with 6 zeros. Okay. So, it works the exact same way. But now instead of out of 100, it's out of a million. Now, one little quick and dirty shortcut, though, sometimes used, especially like in health professions, is rather than having to then convert from that to, let's say, milligrams or kilograms, they like to say, well, there are also 1,000,000 milligrams in a kilogram. So I could also write this as 0.5 milligrams out of a kilogram. Because these are also a million apart. A milligram and a kilogram are a million apart. So that's another little shorthand way. So that you'll sometimes see. So since there are 1,000,000 milligrams in a kilogram, you can just say, oh, well, that's the same as 0.5 milligrams out of a kilogram. So you may also see that way. And again, right, you can always flip these. Right, you can always flip these back and forth. Okay, I'll show you one more. Parts per billion. Parts per billion. So parts per billion, same kind of deal, but now it's not out of 100. Now it's not out of a million. Now it's out of a billion. Oh my gosh, you're so smart. Yeah, we're going to do it out of a billion now, okay? So, for example, the maximum allowed contaminant level of antimony in water, which is a nice poisonous heavy metal, is 6 ppb. So that means out of every billion parts of water, you can have 6 parts of antimony. And a billion is, like Tim's saying, 10 to the 9th, right? That's a billion. Because now it's a 1, right now it's a 1 with 9 zeros after it. Right? That's the same as a billion, 10 to the 9th. All right? 9 zeros. Okay, so again, if that was 6%, you just said 6 over 100. But now it's 6 parts per billion, so it's 6 over a billion. Pretty much the same, right? Works the same way when you're converting stuff. Okay? Well, there was 1,000,000 milligrams in a kilogram, but there's 1,000,000,000 micrograms in a kilogram. So one other way of writing that then is saying micrograms per kilogram. So you could also write this as 6 micrograms per kilogram of water. Because again, these are a billion apart. That's a billion difference. So it kind of already factors in that billion for you, doing it that way. So parts per million, just do it out of a million or do milligrams per kilogram. Parts per billion, just do it out of a billion, or you could do units that are a billion apart, like microgram and kilogram. Thrilling. riveting. Okay, let's go on. Okay, let's talk about density. Well, there's lots of things then we can use as conversion factors from one unit into another unit. So I've shown you a whole bunch of, metric ones, English ones. Now I just showed you a bunch with percentages and parts per million. Well, density is another one. So density is the ratio of the mass of a substance to its volume. So for example, if something is very dense, normally it's really heavy, we say. But if it's not very dense, normally it feels very light. So I'm going to give an example here. Let's say we had a block of ice. Okay, so here's a little block of ice. And this is 1 cubic centimeter, okay? So it's 1 centimeter by 1 centimeter by 1 centimeter. Okay, well, a block of ice weighs a little bit less than a gram, typically. So its density is about 1 gram per cubic centimeter. But if I had the exact, this is ice, I'm going to write ice. Ice, baby. Okay, but let's say I had that same exact size block of lead, right? So same exact size. This is lead. Well, lead is probably a lot heavier than ice, right? Well, that same exact block will now weigh about 11 point something grams per cubic centimeter. So same volume, but there's a lot more mass that's been crammed into that space, so it's more dense, we say. How much matter is crammed into that space? Okay? Just for fun, anybody know what the most dense element is? What the densest element is? You probably not. It's a really weird one, but just thought maybe you'd know. Trivial Pursuit, go on Jeopardy someday. It's osmium. Its density is about 22 something. It's like twice whatever lead is. It's really dense, really heavy. It feels really heavy when you pick it up. Okay, so that's density. But again, so now you see though, this is a built-in conversion factor. I can now convert grams into centimeters cubed. I can now convert between mass and volume. So just another way to convert stuff using the density of something. Okay, so let's try one. So let's say you have a 0.258 gram sample of an HDL, which I think is what, high density lipids, something? No, high density lipoproteins? I forget which one it is. One of those things. Somebody will learn that in your biology class. Has a volume of 0.215 centimeters cubed. What's the density of that sample in grams per centimeter cubed? Okay, so I've got the grams, I've got the centimeters cubed. I just got to divide the two, right? So, are you with me? Here's my grams, here's my centimeters cubed, and I want grams divided by centimeters cubed, is telling me. So let's just do that. Let's just take the grams and divide it by the centimeters cubed. I'll try that real quick. .2 grams per centimeter cubed. Let's check our sig figs though. That doesn't quite seem right to me. How many sig figs are in 0.258? How many sig figs are in 0.215? So how many should my answer have? But just add a 0, right? Now it's 3 sig figs. Before it was only 2. Now it's 3 sig figs. Gotta have the 0. Okay. Awesome. Okay. So here's a little table I pulled out of your book that was interesting. So this here is the density of a bunch of different things that are in your blood, right? So again, these are all densities because they're all mass per volume, right? So the mass of ammonia in micrograms per the volume, deciliter, in your blood, right? So these are all different kind of densities you might see doing a test on a patient or something. Okay, well, as I said, though, there's lots of things, though, that can be used as conversion factors. So I just put up a few little kind of some wacky ones, but not think about being conversion factors. So pull out your handout and we'll just look at these together. Let's just see. So if I wanted to use these as a conversion factor, okay, would it be exact? Would it be have sig figs? How many sig figs? So first I want to write some kind of an equality. So an airliner is traveling at 955 kilometers per hour. Well, so that then allows me to convert between kilometers and hours, right? So I might write that as an equality as 955 kilometers equals 1 hour, right? That makes sense? So I could write that as a conversion factor, either as 955 kilometers per hour or 1 hour per 955 kilometers, right? You can do it either way. You see how I got that right? Okay, so is that an exact conversion? Or will it have some sig figs in it? It has some sig figs. Why? Right, it wasn't defined, right? It was definitely measured, right? That was a measured value. You had to measure the speed. Yeah, so that's measured. So that would have how many sig figs? 3. We would have 3 sig figs in that. And again, the 1 is always exact in whatever your conversions are there. Okay, how could I pull out some kind of an equality out of the next one? A capsule contains 500 micrograms of vitamin B12.
500 micrograms per 1 capsule.
Yeah, so 1 capsule equals 500 micrograms. Yes, you could write it like you said. You could write it as 500 micrograms per 1 capsule, or the other way, right? 1 capsule, right off the edge of the screen, is 500 micrograms. I could do it either way. So, how about this one? Is that exact or is that measured? Somebody has to measure out that B12 into that capsule, right? They're measuring out. So that is definitely has some sig figs. How many sig figs then are on the 500? Only 1, right? Because the zeros are not significant because there's no decimal. Okay, oh, look, here you go, right there. There's osmium right there. I told you osmium was really dense. So you could do that one too. So I could say, okay, so that's the same as saying 22.59 grams is a cubic centimeter. Does that make sense? So you can pull out all kinds of conversion factors once you start looking at the world here. You'll see all kinds of things. Is that a large explosion? Gunshot? What the heck was that? Okay, so 22.59 grams per cubic centimeter, right? So, right, is one way to write that conversion. Or I could write it the other way, right? 1 cubic centimeter is 22.59 grams. Both ways, right? How about sig figs? Is that exact? Is the mass of osmium defined or is it measured by somebody? Somebody has to measure it, right? So how many sig figs? 4. Again, the 1's always considered to be exact. Learning. Fun. Okay. Paying big money for this. Okay. Or not, maybe. Okay. Let's try one. Let's use some of these conversion factors and try, like I said, all kinds of little crazy calculation problems we can do here. So ethylene glycol is commonly used in your car as antifreeze or as coolant. Used for both. Or as you pour it in your car. Has a density of 1.11 grams per milliliter. What is the mass in, what's that DG again? What's that mean? Decigrams of 75.0 milliliters of ethylene glycol. Okay, so I know, okay, let me break this down, the little word problem here, because the word problem is always the thing that was a good student. So I know 75.0 milliliters, right? I want to find what? Decigrams. So my goal is to turn milliliters into decigrams. Well, fortunately, So, back up. So that's a volume going to a mass. And I know that mass and volume are joined by that thing I just showed you called density. And it even gave you the density, right? Wasn't that just so nice of me? So, I'll highlight over here in green so you can see it, right? So here's the density right here. So that converts grams into milliliters. So let's start with what I got, 75.0 milliliters. And my goal is to turn that puppy into decigrams. So what's the first step? How could I start down the road from milliliters towards decigrams? I could do milliliters to grams. How could I do that? Use the what? The top. Yes, yeah, right? Use the density, right? Use the density, because the density does that. The density converts milliliters into grams, right? So how would I put that in here, though? How would I write that in there?
1 ml.
1.11 gram on top, and then 1 ml on the bottom. Everybody see that? Four of you nodded at me. Okay, awesome. Good. Okay, well now I'm in grams, but I want to be in decigrams. What's deci? 10 to the -1. Will that go on the top or the bottom? Hit me with some knowledge. What? Did you say top? Okay. Better go on the bottom, right? Because here's the deci, so the exponent goes on the bottom. Awesome. Okay. So let's try that out. So 75.0 times 1.11 divided by exponent -1. 832.5 digs. Decigrams. Can you dig it? Okay. How many sig figs? How many sig figs should the answer have? 2. Who'd have to pencil that? What is that? How many? 3. Why 3? How many is in 75.0? 3. How many is in 1.11? 3. How many is in 10 to the -1? Exact. So what's the fewest? 3. Thank you, not 2. How'd you get 2? Crazy people. Maybe you forgot your 0.0. Probably I forgot your 0.0. Okay, how do I run that off to be 3 then? What do I put? 833 decigrams. Yay. Awesome. Okay, I'll do one more with you, and I'll let you guys try one. The density of blood plasma, delicious, is 1.03 grams per milliliter. What is the mass in kilograms of 1.0 gallons of blood plasma? Awesome. So, I got a couple of things here. I've got this density. Oh, crap, try that again. I got this density. It was hating me. And then I have this gallon. Which of these am I starting with? So, the question is what? Yeah,
The
read.
1 gallon of blood plasma, because you need to figure out the mass.
Yeah, the question is, how many kilograms are in 1 gallon, right? So I have to not start with this one. And the other little hint in that is, notice how this has 2 units in it? That's going to be a conversion factor. This only has 1 unit, so you're going to turn 1 unit into 1 unit. You can't turn 2 units into 1 unit. That's not going to work. So 2 units, it'll always be a conversion factor. Okay, so I'm going to start with 1.0 gallons. Well, I need to get from gallons to kilograms. So somebody help me down the road from gallons to kilograms. So I need some kind of conversion that has gallons in it. Okay, 1 gallon, it tells you, is 3.785 liters. I just spit on my screen. Awesome. Okay, now I'm in I'm in liters. How can I get from liters, though, still I get to go to kilograms? How can I relate volume, liters, to kilograms mass?
Liters to ml.
Okay. Oh, well, this right here tells me grams and milliliters. So, yeah, I can take my liters and get them into ml, and then I'm a little closer. You see that? Maybe, maybe not. Okay. So, you can go from liters to milliliters. Try that again, right? Here's the milliliters. So I say, oh, well, if I can get towards that, I'm closer. What's milli? 10 to the negative 3. Top or bottom? Bottom. Okay. Oh, now I'm in milliliters. And again, my goal is kilograms. Well, I can't do milliliters to kilograms, but I can do milliliters to grams. Right? So how would I put that into my little conversion factor? What would I write? 1.03 grams over a milliliter, 1 milliliter. Right? Yes, okay. Now I'm in grams. I'm almost there. It's the long one. Now I'm in grams, but I want to be in kilograms. What's kilo? 10 to the third. Would that go on top or bottom? Bottom, right? The opposite of wherever that prefix is. Okay, so now try this on your calculator. Now again, I want to encourage you 1.0 times 3.785, because on top. Oh, that's on bottom. Divided by exponent 3 times 1.03 divided by exponent 3. Oh, I'm sorry, yeah, just remember it was negative 3, guys. Okay. I could say that was negative 3. Try that out, and I'll try that out. And then you may not have time to do one or not. Let's see if we do. $3.89855. Is that what you got? Okay. Let's check our sig figs here. How many sig figs are in 1.0? 2. How many are in 3.785? How do you know it's 4? Why isn't it exact?
Because it's a little wiggy.
Okay, well, that's one way, but how else could you know?
It's
Which system is liters in? Metric or English?
metric.
Metric. Which system is gallons in?
English.
Okay, so we're doing English to metric, so those are never exact. So that's 1, 2, 3, 4. How about milliliters to liters? That's exact, because that is metric to metric, right? How about 1.03? That was measured, right? So that's 3. How about 10 to the third? Metrics, that's exact. So what's the fewest? 2, 4 exact, 3 exact. 2 sig figs. So round that off, and you're going to get what? 3.9 kilograms. Okay, we don't have time, unfortunately. Okay, so do the rest of these. Do a lot of these on your own. Okay, yeah, I gave you, there's 3 more here. So, on the homework for this is due Monday, because we basically finished the chapter. So, work on it over the weekend. You got Thursday, Friday, Saturday, Sunday, and Monday morning. Again, if you have any questions, come see me in my office. Email me. Go to the tutorial center. Go to the FLS on Monday morning at 9 to 10. Any of those things, right, and get some help. And I'll remind you, whenever the whenever the homework is due, there's always a quiz. We're going to have a quiz on Chapter 1 on Monday, too. We'll have a quiz on Chapter 1 on Monday. And then Wednesday's the element quiz. Yes? Yeah. Both sides. Both sides of that green sheet. And that sheet's also on Blackboard if you need it.
And is that also going to need a Scantron for small ones? Or the big one?
You will not need a Scantron for the chapter quiz. That'll be written out, show me your work, set it all up, and all that good
For
stuff.
the element quiz?
Oh, no. That one's a Scantron, yeah.
The small one.
Yeah, the short one, yeah.
Can you help me? I cannot get it to 3.8.